right, ladies and gentlemen. Good morning to you guys. It's always when in this morning, regardless of what the weather is, if I drink my coffee, I'm always sweating. So I hate that. But so hopefully it's been better lately. But okay, so we got a couple of people online. Say good morning, Blanca. Good morning to you. And let's see what we can do here with this. Let me lay the foundation of what you're doing today. So today is kind of like a day we head really into, in some sense, trigonometry, right? And you go, I thought this was trig. And I'll say, well, it is, but it's review of some geometry. Remember this here, right? This is a right triangle, is that right? And we defined things for you guys here, like sine of theta, right? This was that opposite. This was the adjacent side, okay? And then this is your hypotenuse. So sine was opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent was opposite over adjacent, okay? And like I said, this only applies if you have a right triangle with a 90-degree angle there. But then now you say, what do you mean this is no longer geometry? We're now stepping into trig. Well, if I were to say to you, believe it or not, ladies and gentlemen, I can ask you guys these questions here, like, what is sine of 0 degrees? Okay, what is maybe cosine of 90 degrees? What is tangent of, for example, maybe, I'll just say 270 degrees, okay? And then what is maybe secant of 360 degrees? So I'll start with the ones that are kind of the easiest to do. Now, notice something here. This is what you guys want to notice. You see all these angles? Like 0 degrees, 90 degrees, 270, 360? You see, all of those angles you can't do from this what? From this picture. Right? You guys know what I'm talking about? Because theta, the angle theta that they're referring to, theta is between, it's between 0 and what? 90 degrees. Okay? It's between them. So this is what geometry focuses on, ladies and gentlemen, okay? That's the focus of geometry, angles that are between 0 and 90 degrees, because it's reference to that angle there, okay? It can't be 0. It can't be 90. It has to be between, and that's geometry, so you're working with that. Now you go, okay, what are they doing here? They're going to ask us these kind of questions. They're going to even say, what is sine of 135 degrees, They'll even ask us here, cosine of maybe 240 degrees. Okay? So as you guys can see, you may look at this and say, I didn't know you can even ask those kind of questions, right? Well, you can. And that's what trigonometry is here for. It's designed to answer those kind of questions. So in other words, the prerequisite for like a trig course would be geometry, right? Because it makes sense. You're going to now generalize these things. And so you say, what are these answers here? What are these values? And you might even say, well, I don't know. And, it's all without reaching for a calculator, because, you can always say, well, why don't I just buy a TI and just punch that in there and then, not worry about it? Well, Why do you think that's probably not a good idea? Anybody know? In case you can't use a calculator, what if the technology goes down? You gonna know what to do? Maybe not. How about this? There's another good reason, I think. The reason you don't want to just jump to that is because how are you going to build on technology if you don't know how old technology even works? Right? So in other words, how the people that put that information in the calculator, you want to know how to do that. You guys know what I'm saying? So you want to know how to do all those things. It's kind of that simple. Does that make any sense to people? Do you guys know what I'm saying? So if you're going to kind of innovate, you have to know how things work. And that's the idea, okay? So, and it's not that hard to do. Here's what I mean by that. Do you guys know how to answer these questions? You're going to have to use, this is how they introduce this to you. Use what's called circular functions. We're going to use circular functions. And you go, circular functions, yes. So you see these here? What is that called? Circular functions, right? So, good morning, Sarah. Yeah, good morning, Blanca. Brian, good morning. And Antonio, good morning. Good morning to all you guys. Did we get everybody there? Okay. So you're going to use circular functions. What do you guys notice here, by the way? Sine theta, cosine theta, tangent theta, that's still your central angle. We talked about that yesterday. And then I'm going to say to you guys, notice this. What is this? Y. And then what is this? X. And then you say, well, what is tangent? Y over what? X. Of course, you could never divide by 0, so you always want to remember x can't be 0. So, ladies and gentlemen, these are known as the circular what? Functions. Let's get that applause so you guys can write this stuff down. Now, you might say, but you also put sine S, cosine S, tangent S. I've seen S yesterday. So I know what theta is. I know what S is. I don't know what X and Y are. Okay? So this is based on, ladies and gentlemen, a point here, an ordered pair of numbers. It is based on an X coordinate value and a Y coordinate value. Okay? So if you said to me, those are X and Y coordinates, those are known as a point. So 1 point can give you a lot of answers. They're points on what? Does anybody know what they're points on? What circle? Yes. So I'm going to say this. These are points on a unit circle. Okay? These are the coordinates on a unit circle. So, ladies and gentlemen, this is kind of good stuff. You're going to now be able to answer a lot of questions using this. So if you say to me, what do you mean by that? What questions am I going to be able to answer? Well, go back over here. Here's my picture here. Things we talked about yesterday. This here is that central angle. This here is the arc length. Remember that? Arc length along that circle. It's a unit circle. Radius is 1. So this value is important to know. This is 1. Okay, you guys okay with that? And then you say, well, what is this is the X coordinate. Oh, I think we got to use a highlighter. X was green. Y was yellow. That's a point on the unit circle. So this is the basis. This is the mechanism that you guys use. Okay, this is the foundation of how to answer trig function values for non-right triangles. Like if I said to you, go back to algebra or pre-algebra. If that radius is 1, right? Unit circle. What is that x value? Let me go back over here. Let me get the highlighter here. You see this? What's this distance? It's 1. You guys see how I have the 1 down there? Okay. And then you might say, well, what's the yellow? Remember, this is your y-coordinate value. Okay, so that's the ordered pair. It's like the altitude. It's the y-coordinate and the x-coordinate. So we're going to need to have some addresses. I'm going to say focus on this point right here. What's that address if this is a unit circle? What's that x-intercept for a unit circle? What is it? Yes, it is 1, 0. Outstanding. Okay, you guys see that address 1, 0? Now, remember, what's the x-coordinate value? That's green. What's the y-coordinate value? That was orange. So I'm going to remark about this. This is the x-coordinate, and this is the y-coordinate. And so if your ray didn't even move, if that ray didn't even move, what angle are we referring to? Right? You didn't even move that ray. Typically, you start here with this ray, typically, and then like over here, you rotate it counterclockwise, some positive angle, and then that's the theta angle. You go, okay, was that theta? Yeah, that was theta, right? So typically we rotate theta, right? What if you don't even rotate theta at all and it stays there? What angle do you think that's referring to? What is theta going to be here? No rotation means theta is 0 degrees. So if you have no rotation, ladies and gentlemen, theta is what again? Theta is 0. Yes. So what do you think that means we can do? We can start answering trig ratios using that information for what angle? 0 degrees. So you go, okay, what do you mean by that? Well, what's sine 0 degrees now, right? What's that? There you go. What's sine 0 degrees? We need to know the y-coordinate value. What's the y-coordinate value? There you go. Sine 0 degrees is what? 0, because that's the y-coordinate value, right? Do you guys believe me? Let's take a look. Isn't that the y-coordinate value? It's an orange. Ladies and gentlemen, you know what sine 0 is? It's 0. It's the coordinate value on that unit circle. Okay? And there you go. Easy what? What do they say? Easy breezy? Should we double check, right? Remember, it's good to have a calculator, that's fine. But remember, you want to know where this comes from first principles, because it might be that one day you need to innovate with technology and use these principles. Okay, and that's the whole idea. So if I said to you, we can double check on the TI, and I got to make sure, and I can't remember, you guys will probably know, I guess I go to mode. And I got to remember, this has to be in what? Degrees. So I'm going to go down. It's not, it's radians. It's now in degrees. Okay. And I've got to clear that. Sine of 0, sure enough, is what? 0. And you might say, why? And I'll tell you, because of circular what? Functions. It's the definition. What's the arc length if you said, what's that? If I don't move the ray, did I travel on the unit circle? So what's the arc length then? 0. So remember, arc length is that distance along that unit circle. So that's the same as saying sine 0, but in this is now radian measure, our real number measure, and this over here is in degree measure. So ladies and gentlemen, you can find all 6 trig ratios just looking at that ordered pair. X is 1, Y is what? 0. So you say, oh, what do you mean X is 1? Well, what's cosine? Cosine's 1 because what's the ordered pair? X is 1, Y is 0 on the unit circle. Now, what's tangent? Tangent of 0 degrees. What's the Y value? 0. What's the X value? 1. Do you guys know some arithmetic? What's 0 divided by 1? 0. So let me highlight all the answers. I'm going to do this here. Orange, green, green, orange, and your final answer here, I'll put in a box. This is 0. This is 1. And this is 0. And that's just for 0 degrees. Okay, you guys okay with that? That's where it comes from. And of course, if you don't even travel and move the ray, your arc length distance along that unit circle is 0. You didn't even travel. There it is. What do you guys think about that? Is that okay? That's new. What do you guys have to know? These are the definitions of your what? Circular what? Functions. It's the definitions of them. You know, and it really comes from this picture, so you guys know. Okay, now what if I said this? You're going to rotate the central angle 90 degrees. Okay, so now theta here is going to be 90 degrees. Your arc length now, what's the arc length? Distance along that circle of radius 1. Anybody remember from yesterday? Arc length now is what? What is S? Thank you. S is pi over 2, ladies and gentlemen. So all we need to know is that coordinate on the unit circle. It's a y-intercept. What's the address here? Anybody know for 90 degrees? What's that address? 0, 1. Is that important to know? Yes, it is. This is the x-coordinate, and this is the y-coordinate, okay? Theta's 90 degrees. Arc length is pi over 2. Okay, so what I'm going to do now, ladies and gentlemen, I'm going to erase this stuff here. Theta's 90 degrees. Theta is 90 degrees. Theta is what? 90. What was the arc length? Pi over 2. Pi over 2. What does radian measure again? It's simply what? Another way of saying real numbered value. Real number. So it's distance. Like if I moved here a fixed distance, it's that number. Okay? You're just moving along a circle. So y value Oops. Nope. X value. X can't be 0. Y value. What was that ordered pair again? 0, 1. We can answer all of these questions. So what's the y coordinate? 1. You know, sine 90 degrees is 1. Pretty deep. What's cosine 90 degrees? 0. What's tangent 90 degrees? 1 over 0. Okay, you guys okay with that? Now, let me ask you this question, though. 1 over 0, what does that even mean? Is that a value? We know it's 0 over, what do we know? We know 0 divided by 1 is 0, but what's 1 over 0? Yes, ladies and gentlemen, undefined. In other words, there's no value. There's no number. It's undefined. What do you guys think? Undefined. Let's see if the TI agrees. Sine, cosine, tangent of what? 90 degrees, right? So sine now, remember, I put this in degree mode, so that's 90 degrees. Close that. Isn't that 1? Cosine of what? 90 degrees. Is that 0? Tangent 90. It says error. Error domain. I wish these programmers would just put undefined. What do you guys think? Somebody should email the TI people and say, hey, come on. Can you actually use real math terms? Error. Anyway, just a little. If you see error, what does that mean? It's kind of like telling you can't do that. And sure enough, we know we can't do that because you cannot divide by what? 0. That's why they say, hey, x can't be 0, you know, and you're dividing by 0. So that's why there's an error. It's undefined, though. You just say undefined. There it is, ladies and gentlemen. What do you guys think? Is that easy or is that hard? Let's note. Let's see if you're awake. Remember, what's the reciprocal of sine? Cosecant. Could you tell me what cosecant of 90 degrees is? We just flip over this what? Yeah, it's like you say, is that 1 over 1, which is 1 over 1? Isn't this 1? Yes. What's secant of 90 degrees? You say, Mr. Judge, what did you just do, right? You write the reciprocal. This is 1 over. You know, I can actually, well, I don't have space here. Let me do this. I'll give you the definitions. How's that? One over y. Because isn't that ratio y over 1? So what's the reciprocal of y over 1? 1 over y. Good. What's the reciprocal of x over 1? That's right. Give you the definition. Bless you. What's the reciprocal of y over x? That's right. So we could define these here for you guys. So that you can say this becomes 1 over 1, which is 1. This is 1 over, well, yeah, 1 over 0, which is undefined. This is 0 over 1, which is what? 0. So in other words, you can actually find the 6 trig ratios, but take a look at the colors. This is my y coordinate, x coordinate, x and what? Y. All right, you guys see what I'm saying? Definitions are what? Everything. Put them on flashcards. That's how you learn them. Put them on flashcards. So if you're at the laundry doing your laundry, what do? You say, I don't do my laundry, Mr. Judge. My mom does my laundry. Is that right? Anybody here do their laundry? Good for you. I don't want anybody touching my clothes. You want to hear mom criticize you about your clothes? How'd you get that punch? Or how'd you get that stain on your shirt? You know what I mean? You're like, come on, Mom. I was eating some whatever and it dropped some. How do you think I got it? Right? What do you got to hear? You got to be more careful when you eat. You got to hear all that advice all the time. You guys know what I mean? Yeah. Rather do my own laundry. Good for you. You guys doing your laundry. So when you do your laundry, get out your flashcards. When you're waiting in line at the bank, people used to do that. Wait in line at the bank. I don't know if anybody does that anymore. Anybody do that kind of stuff? Wait in line at the bank, get out your flashcards. When you're on your lunch break, get out your what? Flashcards. You guys know what I'm saying? Okay, if you go over to, where's the best burger? You guys are Gen what? Are you guys Gen Z? I feel bad for you. You guys know why? You have no clue what a good burger really is. Because they don't make them like they used to. What you eat now is what? Who knows? I don't even know what that is. Do you guys know that? I hate to say that. You guys don't know that, but there are some pretty good places still. What's a good place to get a burger? Yeah, you can't kind of beat In-N-Out in some ways, at least for the price. In-N-Out is pretty good. In-N-Out is kind of amazing in that they can reproduce that everywhere, you know. In-N-Out everywhere is the same. In-N-Out's good. Anywhere else have a good idea? When you're waiting in line for your burger, get out flashcards. Anywhere you have some spare time, get out those cards. Where's a good burger? You guys usually know. You guys tell me. Five Guys? That's expensive. Five Guys cost some money. And where else? Why is Five Guys so good? Why is In-N-Out so good? It's fresh. It's probably real food. You can see what? There's a Mickey Mouse where? You say Mickey Mouse? I thought I heard Mickey Mouse. It's probably real food. You ever try Burger Lounge? Nobody here's tried Burger Lounge? I think Burger Lounge is good. I haven't tried Shake Shack though. I might have to. I've tried Burger Lounge. Why is Burger Lounge so good? Same kind of thing. It's like real food. In fact, how do you know when you haven't eaten real food? And how do you know when you have eaten real food? After you eat, how do you feel? If you feel like a human being, it was real food. If you feel like, if you ask yourself, what did I just do? Probably wasn't real food. You ever have that feeling? Maybe not. You guys might be young. Maybe young kids don't, I don't even remember what it's like to be young. So maybe when I was young, I just didn't know the difference. I couldn't feel the difference. I don't know. Just something to think about. So when you're in line at Burger Lounge, get out your what? Flashcards. Is Burger Lounge any good? It's pretty good. Even the fries every fry is crispy. You're like, how do they do that? You know how they do it? I asked my buddy, and he's pretty smart, but he says, oh, that's because they changed the oil. It says a lot of times when you eat French fries, you go somewhere, they don't change the oil for like a week or so. Maybe even, who knows how long. He says they might be changing the oil like every day or something. And that's why when you leave after eating Burger Lounge, you don't feel like jumping off a cliff. You know what I mean? You don't feel like, what did I just messed myself up. I don't know what. Do I lie down? Do I take a nap? What do I do? You get that little feeling, in my opinion. That's how you know you've eaten. That's the difference. It's how you feel after. If you feel like you're good and you're like, wow, then you go, okay, there's probably real food. You guys don't notice that? I don't know. It's old man stuff, I guess. What if you rotate? You guys know what's coming next. What's coming next? Yeah, what angle is this? 180. This is like a picture of 180 degrees. He goes, is that my theta? Yeah, I know that's like 180. And then the arc length, though, is another pi over 2. So what's the total? Pi over 2 plus pi over 2 is what? Pi. We need to know this location. What's that address on the unit circle? X is what? And Y is 0. See, this is like on the real number line. See this -1 here? I put a -1 there. So if you know the coordinates, that's the idea. Here's my X coordinate. Here's my Y coordinate, ladies and gentlemen. It's the whole idea. Y is 0 and X is what? -1 for the angle being 180 degrees. And the arc length is pi. So I'm going to copy this here and see if we can erase all this. Oh, and by the way, this handout that I'm working with here, where do you guys find that? I didn't show you guys. I need to show you. Okay, I need to show this to you guys. Just so you guys know, where are you getting those notes from? I'm getting them right here. I go to Math 241 from my website, worksheets and videos. I don't know what I titled it. Unit circle, maybe. I think I should change the title to circular functions. On fire. There you go. Where are you getting that? I'm getting that there. So you can print that up for yourself, at home or wherever. And what's the angle now? Right, 180 degrees. So you're like, theta is going to be 180. Arc length is pi now. I think X was green and Y was yellow. Oops. Where's camera. What's the y coordinate value? What's the x coordinate? Okay, so y, 0 over -1 is what? 0. There you guys go. Yeah. Exactly. Maybe you had to work all night. Did someone throw something? No, don't throw anything. Where's a box? They should throw an eraser. Where's my eraser? I wonder if I can make it. It's pretty heavy, though. You used to have to use a light eraser. Are there light erasers in the room? Did I put no sleeping on the syllabus? I got to put that note to self. Make sure no sleeping. I used to really tell people, if you want to sleep, go outside, sleep on the bench. That's what I do. Did I tell you I used to have a student, she used to bring her blanket? She sat in the back. You might be acting. Somebody might have me on the camera right now. If I ask somebody to poke them, could I get charged for assault? Pinch? If I said somebody, please pinch them. That might be an accessory. I have to ask my wife. Does that make me an accessory? You guys know? That's what my wife says. What about if I said to you, can you give me the reciprocal? Remember, this starts with an S, so I'm going to say cosecant. Cosecant of 180 degrees would be 1 over what? It's 1 over the y value, right? So it'd be 1 over 0. We know that's what? Undefined. There we go. These are like important details because I deal with students in calculus and they go, and I have to talk about some of that stuff, right? And they're going, Mr. Judge, do I really have to remember how to do this? I'm like, yeah, absolutely. So remember, I see the C and I think, oh, the opposite letter, secant, you know what I mean? Secant 180 degrees would be, it's 1 over x, which will be 1 over -1, which equals what? -1, ladies and gentlemen. There you go. Okay? And let me be consistent here. Cotangent. That's going to be what? Definition. Reciprocal. X over y. What's that going to be? Be careful. Yes, -1 over 0. And what happens now? Can't divide. Yes, be careful here. Because remember, on your first test, you're going to be doing this kind of stuff on the first test. And you want to be careful. You don't want to miss that. You know what I mean? Like, man, that was just so easy. I just had to do the reciprocal and I didn't. Those are the kind of things that I get mad at myself if I, like, man, I didn't do the reciprocal. Okay, you guys see what I'm saying? Circular functions, you know. And then you go, okay. If we rotated an additional 90 degrees, What angle is that now going to be? We're going this way. Yeah, we add another 90, is that right? And that's going to give you how much? That's 270 degrees. And you go, okay, 270. What's the arc length now? Yeah, this location? Yeah, x is 0, y is -1. Okay? So I think, yeah, x is green. So this is now a 270-degree angle, rotating counterclockwise from that initial side. What was the arc length? 3 pi over 2, good. Zero, -1. So I'm going to kind of... So now the angle would be 270 degrees. The x values, here's the y values. Okay, pretty simple. What's the y coordinate? -1. What's the x coordinate? 0. Y over x. -1 over 0 we know is undefined. Yes, there you guys go. And then you could get the reciprocals if you said, okay, the reciprocal of sine is cosecant 270 degrees, right? So it'll be 1 over, that's the y value, -1, which is -1. Okay, so always remember this is the y coordinate value. And then secant of 270 degrees is 1 over the x coordinate. That's the definition. And we know my x coordinate is 0. So you go, oh, 1 over 0 we know is undefined. All right, now you say, what about cotangent of 270? Well, cotangent 270 is 0 over -1, and we know that makes this what? 0. So what do you guys think about that? Is that okay? I want you guys to note something. What if you said, okay, what's sine of 3 pi over 2? What's that going to be? That's right, -1. So in this case, this is a radian measure, a real number measure. So they can ask you either questions. What's sine of 3 pi over 2? You go, oh, what is 3 pi over 2 anyway, Mr. Judge? That's 270 degrees. So it's the same exact answers. This is why you see equal here all the way through. Okay? Just want to see if you're awake with that one. And then, ladies and gentlemen, what if we rotate another 90 degrees? And you go, what do you mean? Yeah. If we rotate, what do we say? This is 360 degrees, right? 270 plus 90, is that 360? What's the arc length associated with 360? 2 pi. Good. So this arc length now will be 2 pi, okay? You might say, can I do that? Yeah, you can rotate 360. Notice you are right back where you what? Started. You know what we call this, by the way? I want you guys to note. 0 degrees and 360 degrees. You know what we call this? These angles are related. What are they known as? Outstanding. These are called coterminal angles. They share the same terminal side. Coterminal. You know, it's kind of interesting. Like I said, chapter 5 and 6 are kind of like parallel chapters in a way. When I read this book, you know, the author did this way. And this is actually the definitions in like chapter 6, but we're also working in chapter 5. So they're kind of, you could go back and forth. Coterminal. I'll give you those definitions, you know, soon, because, you know, they can ask you now. I'm not even going to focus on 360, right? What I'm going to do now here is this. I'm going to say that if we know that those coordinates, all we got to know is that point. Just got to know that point. And instead of saying, what is this in degrees, they can ask you all these questions in terms of radian measure. And it's all about, just like going back to pre-algebra or beginning algebra, knowing how to plot points. You're actually seeing that in intermediate algebra because this is equation of a circle. But has that same address, right? I can say, what's sine of 2 pi? What's cosine of 2 pi? What's tangent of 2 pi? I'm gonna say it that way instead, because we should be able to answer that in terms of the radian measure as well. You know, it's no big deal. So it's the same answers, meaning, I guess this is orange, right? Orange, orange, green, green. Isn't that 0? Because it's the y coordinate value. What is the x? 1. Y over x. 0 over 1. Oh, we know that's going to be 0. And you now found tangent of 2 pi. And I know, what is that as a degree? 360. There you go. Yes. Go back to the circle. Yeah, when you start this ray, and I can erase some of this stuff so you guys know. You got that? You got that in your notes? You okay? I mean, I could give you guys the definition here, but you okay with that? So I can kind of give you some of that definition here when you're looking at this particular picture. Because, you know, definitions in math, like anywhere else, are the most important things. Without definitions, you can't answer questions. It doesn't matter what the subject is. You could take sociology or psychology. Without the definitions, you can't say anything. Right? What's the definition of bipolar? Don't know. What's the difference between what's the definitions of a narcissist? That's pretty, I don't know what that is. A psychopath. A sociopath. Anybody know those definitions? So without them, you can't have a conversation in that topic. It's just like this. Without these definitions, you can't have a, conversation. So let me just let you guys know. This is called the initial what do they call that? And the initial side of the ray, the initial ray. This is called the terminal ray. You say, why is it called terminal? This is like initial means to do what? Where you start. Terminal means where you what? End. So you're supposed to be rotating counterclockwise. So you have the starting ray and the ending ray when you rotate. It creates this what? Central angle called theta that has an associated arc length. Okay? And in fact, the author does this as well. The author defines this location as, I say IP. What do you think IP stands for? Initial what? Point. Yes, initial point. And this is called TP. What does that stand for? Terminal point, ending point, starting point, ending point. That's all on the unit circle. Starting point, ending point. And in fact, did you guys read that section? The author doesn't use S. The author uses T. I think he calls that a T number or a T value. I don't know, something like that. It's really arc length. I say just use what it's called. It's an arc length. Use what it is. So again, here's some language here. Now, the reason I bring up some of this language here is because, we'll start to use it and refer to it. But what I'm going to say here is this. What if this angle here, I didn't want to erase everything. What if the angle is 45 degrees? We know that we can convert, and this is what? What's the arc length with 45 degrees? 5/4. Remember we converted that yesterday? Okay, so here's my initial point. Here's my terminal point. Okay. Yes. If I know this coordinate here, if I know the XY coordinate, you know what I can do? For 45 degrees, I can now do what? I can now answer what sine, cosine, and tangent is. You can say, Mr. Judge, I'm going to give this to my younger brother and sister. They can already do it. They're taking geometry. You know what geometry really is? Right here, quadrant 1. Just kind of throw that out there so you guys are going to refer to it again. Anyone know these coordinates? How do you get these coordinates? Right? How do you get the x coordinate again? The x coordinate is this distance down here. Is that right? And the y coordinate is this distance right here. Anybody happen to know what those coordinates are and why? Yes. Anybody ever see that before? That's your special triangle, isn't it? Do you guys see what I'm saying? So this distance down here is a square root of 2 over 2. This distance is a square root of 2 over 2. That's this location here. So you have the x coordinate and the y coordinate. Okay? Quadrant 1 is geometry. See, Mr. Judge, we already know quadrant 1 information. All right. Fine. If you know quadrant 1, let me see what I have here. I might already have a nice picture of this. No, don't look at that one. I think it's this one. Yeah. This is 45 degrees. We know this address is a square root of 2 over 2. And this address is a square root of 2 over 2. You guys with me on that? So I'm going to use a cleaner picture. What we want to find is this. What is this location? Let me get the highlighter. This location, and this location. Because right in here, this is what we know from what? Quadrant 1 is geometry. We want to find those points in quadrant 2, 3, and 4. Okay, you guys with me on that? I got news for you, though. Let's use some information. You see that angle 45 degrees? I make the claim I know what this angle is. How do we know it's 45? Yes, outstanding. Opposite angles of vertical angles. All right, you guys okay with that? So what I'm saying is this also is what? 45 degrees. We could put that little line there. Can I tell you something else? I even know what this angle is. That's also 45. You might say, why? Why is that also 45? Yep, complementary angles, 90 minus 45. Absolutely. And so, in fact, this is 45 everywhere. Is that right? Okay, just kind of checking to see what you guys are thinking. What else do I know about a circle? A circle is highly, highly, highly what? Symmetric. Would you guys agree with that? Isn't a circle symmetric? We're going to take advantage of that symmetry. So, if this distance was what? The square root of 2 over 2. Excuse me. You see that distance here? What should that be? Yeah, that's good. Oh, that's the same distance. Okay? It's the same distance. However, what's the story here? X is minus the square root of 2 over 2. See this here? Any number here to the left of 0 is negative. Is that right? And then what about this distance here? How high is this? You might say, Mr. Judge, I don't know how high that is. Yes, you do. How high is that? That's the same height over here, isn't it? So in other words, this is what? That's also square root of 2 over 2. There it is. Because of what's the word? I thought I wrote it down. Did I erase it? Because of symmetry. It's because of symmetry. Remember what we said yesterday? This here is a quadrant what? 2 point. Quadrant 2 points, what's the deal? X is negative. Yeah, Y is what? Positive. Remember that from yesterday? That's why the symmetry idea and knowing the points are going to be important for us. This is why the x-coordinate is what? It's negative. So this is green. This is green. Orange and what? Orange. Okay, you guys okay with that? Pretty good? Can you tell me what these other points might be? Maybe you guys already know all this stuff. What's that location on the unit circle? What's the x-coordinate again? Negative square root of 2 over 2. And then, oh, what happened now? The y-coordinate down here, oh, it's opposite because of symmetry. It's also what? Negative. So in quadrant 3, didn't we say both x and y points are negative? So I want to point that out, ladies and gentlemen. The symmetry is for the circle is what you're going to use. And then here you got this location. And, you know, we can draw the same kind of pictures, I guess. The x-coordinate now. You guys see the x-coordinate is positive, right? And the y-coordinate's what? Negative. Square root of 2 over 2 and minus square root of 2 over 2. Yeah, I shouldn't do that because it's the whole thing. X, y coordinate. So, ladies and gentlemen, you're taking advantage of this word called symmetry. Because a circle is highly symmetric. So if you know quadrant 1 information from geometry and algebra, you know quadrant 2, quadrant 3, quadrant 4. So, you know, I like to, when I think of this course at times and I describe it to people, say, yeah, geometry is quadrant 1. Trigonometry is the other quadrants. 2, 3, and 4. Okay, so you're just going to use symmetry. There's one other thing I have to talk about, though. Because this is in regard to what angle? 45 degrees? You see this here, this sheet? So when I designed this for people, this is the geometry version. I put it in purple, right? You could do that from geometry. And I'm going to say something even further. I'm going to put this in the asterisk here. This is your reference quadrant. It's the reference quadrant. Quadrant 1 is going to be your point of what? Reference. So it's vital that you know quadrant 1. And all you have to do know, really, for quadrant 1 is 45 degrees, 30 degrees, and what? 60 degrees. I'm going to say that again. 30, 45, and 60. That's all you really have to know. 2 special triangles. If you know that, you could deduce everything else. So if you said to me, you have me have 45 degrees, what do you guys know about this angle over here? 135, 225, 315. This here is quadrant 1, and this here is quadrant what? 2, quadrant 3, quadrant 4 angles. But they're associated with your reference of 45 degrees. This is a reference angle. Okay, you guys okay with that? Should we try one problem? I'm going to try one here. I'm going to have to erase a lot of this, though. Let me do this. Yeah, I don't want to erase. I find really what starts to happen is this gets a little distracting, right? So we already know how to find quadrant 1. The questions will be, how do we find quadrant 2? Yes. Only for what? Yeah, this address here? Yes. Let's put a purple dot. How's that? Quadrant 1. You okay with that? Let's do purple. Let me show you our reference here, right? So what they want you to know how to do is, here's my terminal, my initial side, the initial ray, also known as the initial side of the angle. And then I'm going to rotate it this way. Okay? What angle is that? What's theta? Here we know what theta is. Isn't that 90? So you can say, I'm going to rotate it, Mr. Judge, this way first. Right? 90 degrees. And then you're going to say, I'm going to add an additional, what was this? 45. You guys remember that? So you say, I'm going to add 45 degrees. What do you think that gives you? 100 and what? 35 degrees. So this angle here is a 135 degree angle. You can find the arc length. You say, how would I find the arc length? What's the arc length? We did that yesterday. Convert it. Three pi over 4? You know how I know it's 3 pi over 4? From here to here is pi over 4, 2 pi over 4, 3 pi over 4. Anyway, convert it. We're on our way. We're on our way. You guys okay with that? So I know the angle is 135 degrees. Arc length is 3 pi over 4. And I'm going to give you guys a definition you're going to use. So you see this here? Why is it purple? Your book says this is called, you see this little asterisk? The book calls it T asterisk. Anybody know the name of that? The book calls this a reference number. So let me give you the definition of a reference number for circular functions. You're going to use this for a long time. I call it like the reference angle. Your book goes to radian measure and calls it reference number. Okay? So the reference number is defined to be, it is the shortest distance along the unit circle from the terminal point, endpoint, to the x-axis. Shortest distance, terminal point, to the x-axis. This is called a reference number. Okay, and so if we go back there and you say, well, unit circle somewhere, circular functions, there we go. Remember this is called a what? Initial point, what's this? Terminal point, And where's the x-axis? I should use a different color. There's the x-axis. So the shortest distance along the unit circle is there in orange. Purple. Would you guys agree with that? That's the definition. So you say, oh, this is the shortest distance, terminal point to the x-axis. I mean, you say, what's the other one? Well, I could go this way. Has to be along the unit circle. That's bigger. So this is my reference number. You know what you're going to find that reference number is going to be? What is that distance? It's going to be pi over 4. So here's the deal, right? So let me say this to you guys. If this is 3 pi over 4, this is pi over 4. What's pi over 4, by the way? 45-degree angle? So what I call this is really the reference angle, personally. You go, why is that a reference angle? It's a quadrant 1 angle, 45 degrees. So your book says, okay, use pi over 4. I think pi over 4, 45 degrees. This is the information I use. I have to know the quadrant 1 locations. And if I know quadrant 1 locations, you know what I think of? I shouldn't erase that. I just think of quadrant 1. What was all the information we did for quadrant 1? If I went back, that's not quadrant, right? You see, what is my x value? This is the x and y for quadrant 1. This is my point of reference. Square root of 2 over 2. Square root of 2 over 2. What is sine? Is that x or y? Square root of 2 over 2. What's cosine? Oh, they're the same. What's tangent? We didn't. What about this? Tangent of pi over 4. Square root of 2 over 2 divided by square root of 2 over 2. Isn't that what? 1 and so on. You guys see the point? You could get the rest of the ratios, blah, blah, blah. But what does this have to do with the 135? Very easily. What's that terminal point again? X is what? X is negative. Y is what? Positive. We know that location. Negative square root of 2 over 2, positive square root of 2 over 2. You can use that. Or X is what? Negative. Square root of 2 over 2. Y is what? Positive. So sine, was that the X or Y coordinate? Cosine was the X coordinate, so it's negative. What's tangent going to be? Negative 1. Because y over x, okay, y over x for tangent, this is now for 135, ladies and gentlemen. And then the arc length, we already said here was what, 3 pi over 4, I guess? Yeah. And of course, you can find cosecant, secant, cotangent as well. So, ladies and gentlemen, this is the start of using the unit circle, the terminal point, finding that shortest distance. But the wisdom I have to say to you guys is this. Geometry. This is purple. That's quadrant 1. The other quadrant angles can be deduced. Those ordered pairs, x, y, will change in signs. And so here I started with 30 degrees. Meaning the quadrant 1 here, this is a 30-degree angle. It's the same definitions. You get this reference point. You're going to be able to use that. Just change the signs for sine, cosine, and tangent for whatever quadrant you're in. Okay, we're going to see this. We're going to see the coordinates there. And also for what? This one actually is 60 degrees. Geometry. So this here, quadrant 1 angle, we're going to see this is going to be what? 60 degrees. You just need those particular coordinates here. And you'll just change your signs for the x and y values depending on the quadrant you're in. And that's going to be how you start to deduce sines, cosines for other angles. You say, what other angles? This is kind of like the family of angles, 60, 120, 240, 300. You guys know? And then after that, you know what I did here? Unit circle summary. So what I would say to you guys here, you guys can get started on all of this in some ways. Because I remember one year, you know what test 1 was for class 1 year? It's not going to be your test. I learned from this. I had them do what? Deduce all these answers. I had them do the summary for test. That was their test 1. I wouldn't do that again, though. You know why I wouldn't do it again? It's tedious to grade. Tedious. I had to look at every detail so closely. If you miss a sign, negative, you know what I mean? You got it wrong. So tedious. So that was the first and last time I ever did that. But what I want to remark, though, is that, is this important to deduce on your own without a calculator? Yeah, first principles. So what I'm going to do in your homework here, so that people know, so hopefully you guys can get started on that. This is the unit what? Unit circle. And hopefully 6.1, some of the stuff that you may have read should be designed to help you to some degree. And maybe read 5 or 5.1 too. Yeah, 5.1 should help you in that. If I can get rid of this. Do you guys know what I'm talking about? Some of those different definitions were there. So I want you guys to fill in that unit circle. We're started to do it. You know, I didn't show you how to get the terminal point, quadrant 1, using, it's from geometry. You guys already know it. It's just special triangles. See what you guys can do with that. Okay, you guys okay? Anybody have any questions before we go? Is it going to cool off today? Bless you.
The unit circle, we just need to fill out the chart, right?
Yeah. And it's an exercise, but it's an important exercise. I mean, that's what chapter 5 wants you to do, in all honesty. Anyway, okay, we'll see you guys later. Take care. Trigonometry scratch. All right, so here's something to always kind of remember, I guess. And I think I got to draw, try to see if I can draw a nice version. I'm not so sure. Okay, whatever. So when this is 45 degrees, if you guys remember, we looked at this being 1, and this being the square root of 2. Is that true? So what was the name of this triangle? If you guys remember. What was this? 45. What else? 45. 90 degree, and that's a special triangle, and that's important. And there you go, ladies and gentlemen. And there you go. But if I said to you guys, this is 30 degrees. Do you guys remember the special triangle that we created here? Right, this was 1, and then what was this side here? 2, is that right? And this side was what? The square root of 3. Are you guys okay with that? And then this was known as, remember, this is 60 degrees because the 30-degree angle and that angle there needs to be supplementary. So this is going to be a what? 30, what? 60, 90 degree what? Special triangle. All right, you guys okay with that? Now, the reason I bring this up is because I want you guys to focus right in here at this very special point. Here and here. I think I've been trying to draw this here. We'll leave that maybe as orange and leave this here as green. Okay, because in that picture of your circle, and let's try to draw a circle. X-axis. Y-axis. Okay, let me do this here. Generally speaking, this is that radius. Is that right? If this is a unit circle, here's your radius. What does that measure again? That measures what? 1. You guys okay with that? And then what we're trying to get our hands on is this location here. Is that right? This is called the terminal point. And that terminal point, you know, you say, well, what is that? Well, this is my initial point in the book. Right? And here's that angle here, theta. Theta's positive again. Okay, all these pictures we've been looking at over and over. The point I want to make to you guys is this location is your terminal point for these triangles. Right? You got the x coordinate and you have the what? Y coordinate. So you got an x coordinate and you have a y coordinate. Okay? So this is the radius in the picture here. Actually, I made a mistake. This is not true. Is that true? There's a big mistake here. That can't be the radius of 1. You guys with me on that? What's going on? That's not right. That's not right. So what happened? This is the issue. How can that be if this radius has to be 1? That's not true. Anyway. Well, let's do some math. What do you guys think? You guys want to do some math this morning? I'm going to share with you guys another approach to this. This is a very rigorous approach, though, of the 45, 45, 90-degree special triangle. I'm going to copy this. I'm going to do this in such a way, I want to make this radius what? 1, and that radius 1. We're going to use some algebra. What do you guys think? I mean, that's why we're here, right? So we might as well get paid to do it right, do it the right way. Okay, so ladies and gentlemen, here's what I mean by doing it the right way. Compare and contrast. Remember from geometry, you have this idea called similar triangles. Remember that? If this is x and this is x, so I'm going to do this in general. I'm going to look at all these very similar triangle versions of this right triangle. You guys okay with that? Because there's infinitely many right triangles that are 45, 45, 90 degrees. You say, what do you mean infinitely many? Well, you see how I say this is down here, what? This is x and this is x? That should make sense because this came from a square. Do you guys remember that? You say, what do you mean? Yeah, remember we said this is like a square, this is x and this is x? We're going to find that diagonal. I can call that, maybe I'll call that D. How's that? Let's call that D for diagonal. So we're going to look for that diagonal D. You guys remember? So here's what we're going to do. We're going to say what? D squared is x squared plus x squared. You guys okay with that from the Pythagorean theorem? All right. Now, you might say D squared then becomes 2x squared, or, yeah. And then now we're going to say what? D becomes plus or minus square root of 2x squared by solving that using the square root formula. So now distance is positive. We get to simplify this rational, okay? What do I mean by simplify the rational? The x squared is a perfect square. So what I teach in intermediate algebra, we get to use the square root of a product is product of square roots. And so what happens now here is this will be x. So we get the distance will be square root of 2x. Or some folks will simply just write this as x square root of 2. Okay? And there it is. So you might say, what did you just do? We found the diagonal in general. All right? We found the diagonal. What's the formula for the diagonal? It is x square root of 2. So I can go back here and say you are now going to be what? X square root of 2. Yes. Yeah, it comes from a square. Yeah, it comes from a square. Remember, sometimes you have seen squares defined this way. I mean, they don't use the letter X, they might use S for side. Right? I don't want to use S because there's already too many letters, you kind of D, S, X. S is for arc length. Anyway, but the answer is yes. So here's my point to you guys. You know what you can do? You see this portion right here? What do you say with that? x squared root of 2. Here's what we say. We're going to let x squared root of 2 equal what number? 1, that radius being 1. You know what that means when you solve for x? X is 1 over the square root of 2, ladies and gentlemen. Now, why is that such a very, very big deal here? X is going to be what? 1 over the square root of 2. What that means here is this. I can say this x is what? 1 over the square root of 2. This x is 1 over the square root of 2. And then this radius is really what? 1. I got my unit circle radius. Now, when you rationalize, again, you might say, no, Mr. Judge, isn't that the square root of 2 over 2? Because I rationalize, and I'll say, yes, square root of 2 over 2. But this is a way, I should say, this is really the family of circles, the similar triangles that are 45, 45, 90 degrees. And they have different lengths down there. Okay, so if you look in the book and you go, wow, they put 1 here for the 45, 45 triangle, and then that terminal point is square root of 2, square root of 2 for the 45 degrees, you'll say, Mr. Judge, is this why they have that x coordinate being what? Square root of 2 over 2. And the y coordinate being what? Square root of 2 over square root of 2. This is not to scale. I apologize for that. Here's the x coordinate. Here's the y coordinate. So, ladies and gentlemen, what they've done was looked at the general version of this. Okay? And they did a little bit of algebra. And so this is now where that location comes from on that unit circle for 45 degrees. So forever in your life, if you see that picture and you go, where did they get that 1? Well, it's, this is what they did. They needed a radius to be 1 on a unit circle. And that's why this terminal point is so important for us. This is the stuff we looked at when? Last time. Do you guys remember? Was it here? I'll just summarize it here. Okay. Square root of 2, square root of 2, square root of 2, square root of 2 for 45 degrees, that 45, 45 right triangle. This radius is 1, but this is that terminal point you guys want to be, familiar with. Okay, now my arm. I hope so. Let's get this. Sorry, I hope so. I did some things about 2 weeks ago, some old man stuff. Never thought it'd be possible. I don't know. I was lifting these cabinets. I was doing all kinds of physical work. Carrying around these guitar cabinets, 412s and 212s, and lifting them and moving them around, and then, soldering speakers in, bending over, and then I did that for 2 days, and my back was killing me. My back's fine, but my left arm still is problematic, so don't know. Old man stuff. Huh? No. I think it was partly AC stuff too, because when I go to sleep I try to put the AC on, and you know what I mean? There might be who knows? Don't know, man. Yeah. Told my wife, hey, I did this 2 weeks ago. Look what my arm is. So I got this massager, and I did it yesterday, and made it worse. Weird. So now I'm trying to. Anyway, old man stuff. What did we do last time? What's the whole point of finding that location? So that we can find this location, and this location, and we can actually find our 6 trig ratios for different angles and on the unit circle, right? Using circular functions. That was the whole point. So do you guys want to tell me what's this coordinate axis, or what's this terminal point? I'll say TP terminal point. What's this terminal point? It's very simple. Once you get the quadrant 1, here's my point to you guys. Quadrant 1 is geometry. Quadrant 2, 3, and 4 are trig. So once you get quadrant 1 information, what do you guys get here? What is this? Negative square root of 2 over 2 and what? positive square root of 2 over 2. Is that true? All right, good job. What about this down here? What is this? Negative square root of 2 over 2, and then this is negative square root of 2 over 2. Good, they're both negative, is that right? And then what about this one over here? Positive square root of 2 over 2, and then what? Outstanding, ladies and gentlemen. There you guys go. How we got what? Oh, how we got 1 on this here? Because you know what we did? We got that formula when we used that scratch, right? Remember we got this here, that the formula is x squared root of 2. Set that equal to 1. So right in here, this is a computation. So the question is, how do we get that diagonal to be 1? We said, let the diagonal equal 1 unit, and then solve for x. So you said, how do we get that to be 1? We said, let that be 1. If it's 1, we could get the x value. That's what we did. Okay? So, and that's really explaining something extremely important for us that we talked about last time. Because I'm going to give you guys a summary of this as well, and hopefully you guys like that summary. Anybody know where I'm going with this? All students take calculus. What does that mean? All students take calculus. You should. All students take cash?
No, strippers.
Oh, strippers take cash. Don't know anything about the topic, ladies and gentlemen. I say all students take what? Calculus. Don't know anything about the other topic. That sounds like a high school thing. I'm glad I'm not in high school anymore, by the way. High school was horrible. That's funny though. So what does all students take calculus mean? A, S, T, C. We'll talk about that. All right, we'll talk about all students take calculus. So then you say, well, what does this have to do with the 30, 60, 90 triangle now? Right? How do we get, remember, what does this have to be? If this is a what again? Unit circle, and this is 30, 60, 90. I think I want to do the 30-degree angle. What happened here? Did I start with 30? I might have started with 30. Start with 30. Here we go. See this point? Is 1. This is what? 30 degrees. Okay? What's this terminal point? Because once we have that first terminal point, we have the others, and then we can roll with all this. Let me get my mask. So go back to the scratch work. You see the scratch work? How you doing? See the scratch work right up in here, right? You say, Mr. Judge, that diagonal is 2. How do we get the others? There's a formal way to do it. Let me share with you guys the formal way, okay? Remember how we started this? We created an equilateral triangle? Remember the equilateral triangle? This is 2. Here's what I'm going to do. I'm going to say this is 2x. Okay? And if I bisect, which means cut in half, what do we get? Focus on this left side. This is now x. This still is 2x. Is that true? That doesn't change. See, this diagonal is 2x, right? But the length down here, when you bisect this, if that's 2x, this is now x. Okay, so I just want to let people know that. And this is the 90-degree angle. We don't know what this is, but by Pythagorean theorem, we say x squared plus triangle squared becomes what? 2x squared. X squared plus triangle squared becomes 4x squared. Triangle squared, if I subtract x squared from both sides, don't I get 3x squared? Right? If you want, let's be consistent. I apologize. I want to call this, oh, I don't know. What do we call that? Darn it. I guess we can leave it as triangle. That means a triangle becomes plus or minus square root 3x squared. Again, distance is positive, so that question mark is positive. And then use properties of exponents to simplify your radical, which is square root of 3, square root of x squared, which is square root of 3x, or we say x square root of 3. So here is that, the length there, okay? Okay, so this is where this comes from. Now, what are we going to let this be? Because remember, this is 60 degrees, and this is 30 degrees, right? 60 degrees, 30 degrees. So what do we let that diagonal be if we want to find the other dimensions? What do we let this 2x be? Do you guys want to let me know? Just like the last example, what should 2x equal? Good. If 2x is 1, what does that mean about x? Yeah. So this is 1 over 2, and this is 1 over 2. So if you've seen this here, (30, 60, 90), this is 1/2. This is the square root of 3 over 2, and that's 1, ladies and gentlemen. Okay, so that's kind of the algebra behind it, and that's something you look at in geometry. Hopefully they looked at all the similar triangles that are 30, 60, 90, all 45, 45, 90-degree triangles, you know. So you have 1/2 square root of 3 over 2 and 1, 30, 60, 90. So that's where it comes from. Now, this here, the whole point is this. This is my x value, and then this is my what? Y value. So you see this here? What's the address of that terminal point? 1/2 square root of 3 over 2. That's where it comes from. 1/2 square root of 3 over 2. All right, you guys okay with that? So let's go back to that circle. You go, oh, is that why they have this as what? 1/2 square root of 3 over 2. All right, you guys okay with that? Now, what's this other location here, this point? Once you have this address, what's this? Because remember, this portion, quadrant 1, is geometry. Quadrant 2 and 3 are trig. So what's the address there in quadrant 2? What's the terminal point address over here? Do you guys know? Negative 1/2, what? Positive square root of 3 over 2? Because what do we know about x again? X is negative. Yes. Say that again. No, not when it's in quadrant 2, 3, or 4. Oh, I think, yeah, I think it could do that. I think what you're saying is this, if I understand that right. You're saying, could I conclude a right triangle where this is what, 30 degrees here? Yeah, you could. You could. But just remember, and this is kind of a problematic thing. When we use Pythagorean theorem, distance is never what? Negative, right? So now if you did that, this distance is negative 1/2. And it's only because it's where? To the left is 0. See, now once you superimpose that triangle on a Cartesian coordinate, xy plane, some values are negative. But that's kind of where people might go, wait a minute, I thought you were saying, hey, these distances are never what? Negative. You know what I mean? So just be aware of that. Can be done. In fact, I'm going to summarize it for you guys soon, and hopefully you guys go, okay, I can see that. Yes. I might have made a mistake. Where's my coffee? Let's double check. I think you're right. This is a 60 degree. Yeah, thank you so much. That's why this is where we did it. Okay, you're absolutely right. This is what? 60 degrees, and this is what? 30. And you go, well, what's the difference, Mr. Judge? Isn't that the same triangle? Well, I'm going to do something here for you guys. Here's what I'm going to do. The reason, this is one triangle. But if I were to rotate this triangle and make this, what, 30 degrees, which is what we wanted to do, and this is 90, and this is 60 degrees, I have to rotate the top triangle. And the angles next to it are going to be, this is what? Square root of 3 over 2. And this is 1/2 now. And you're right. And so the x value here, down here, this is the y value. So there's different triangles, and you're correct. It is, in fact, reverse. So let me apologize for that. It's the square root of 3 over 2, and it's 1/2. It is reverse, but we're going to look at both of them. That's the whole idea. Square root of 3 over 2 starts the conversation there. So you're right. Okay. So let's put that in. Now, what about this next one over here? That means this is negative square root of 3 over 2, right? And 1/2. The bottom terminal point is what? They're both negative, aren't they? Aren't they both negative? And then over here, you got positive square root of 3 over 2, and then what? Negative 1/2. Okay, and that's for 30 degrees there. And then what am I going to say this? I'm going to say this again to you guys. What am I going to say? You guys know? All students take what? Calculus. But I have to share this stuff with you guys on the unit circle. I do. Now, what was the other angle? See this? This is 60 degrees. What was that terminal point again? Over here, if that's 60 degrees, remember you make this triangle. That's where it came from. Remember we said, oh, it's 45. Oh, it's backwards, right? So this will be what? 1/2, and this is? So in some ways, if you only have quadrant 1 known from geometry, you can very easily deduce the others. Is that true? What's this point going to be? Negative. Good. That'll be what? Negative 1/2 square root of 3 over 2. And then what's this one down here? Negative 1/2, negative what? Square root of 3 over 2. And then what's this one over here? Positive 1/2, negative square root of 3 over 2. What do you guys think? Now you can deduce trig values for a lot of different angles. Not every angle you can think of. Again, what am I going to say? All students take what? Calculus. You might say, Mr. Judge, why do you keep saying this? Do you guys know why I keep saying all students take calculus? Yeah, what does this mean? Let me see if there's another worksheet. So if I said to you guys, let me go to my website. Go to this website here and go, okay, we're in trigonometry. I'm going to have to... Math 2, what, 41? All right, worksheets and videos. All students take calculus unit circle? What? Boy, when are you going to get away from these unit circles? Let's put that in there for you guys too. Where is this at? Where are you guys? Come on. What's on this sheet anyway? Oh, it's just that picture. Wow. Okay, let me express this to you guys here, all right? If we go back to circular functions and the definition. Remember I said you guys have a table to do? Let's go back here. Anybody do that table that we're talking about? You guys know where this all students take calculus come from? Remember, this is all based on what? Terminal points. Let's go back here. I do this. I'm going to do this for you guys. Quadrant 1, this is all. That means all three trig functions are what? Positive. That's what the all stands for. Okay? Why, ladies and gentlemen? Why are all three trig functions positive? Right? See that terminal point x and y? What do you know about that? X is positive and y is what? Positive. And what's the deal? How are they defined? In terms of positive x and y values. That's why we can say all students take positive, or all students take calculus. Okay, you guys okay with that? Now go to quadrant 2. What do we say here? Students, what does S being positive mean? In quadrant 2, what does that mean? Sine is what? Positive. So why is sine of the angle positive? Because what's the definition of sine? It's the y-coordinate. And in the y-coordinate here, it's what? The y-coordinate is positive, is that right? It's the x-coordinate that's negative. So if you say, x-coordinate's negative, but the y-coordinate is what? Positive. That's the whole idea. Okay? But it's more than this. Sine's positive, but what is negative? Cosine is what? Negative. You say why? Because it's the x-coordinate value. Remember how that was important? It will be. It will be. But we can get away with it by just doing, you see this little x less than 0? So now we say x is less than 0, so that means x is negative. And then you say, well, why do we only say sine's positive? Well, what's tangent? What's the definition of tangent? You guys remember? Y over what? X. What do you guys know about x? It's negative. What do you guys know about y? It's positive. What's a negative over a positive, I guess? Or a positive over a negative? So I can do this even. I could represent tangent being negative by saying less than 0. The point I want to make is this. Sine is positive in quadrant 2. The others are negative. So if you have quadrant 1 information, geometry information, I always say this is your reference quadrant, your reference angle, reference quadrant, your point of reference. If you know this, you know the others. You just have to change signs. Yes? That would mean sine's positive and cosecant's positive, yes. But when you use the acronym of all students take calculus, remember, it's in reference to the 3 trig ratios. Okay, but then you could deduce the other 3. Yeah, that's how it's done. And really, in all honesty, ladies and gentlemen, that's how I look at this personally. But you have to go dive into the details so that people know where it comes from. It's always good to know where something comes from. You're more likely to remember it and believe in the acronym all students take calculus. What about quadrant 3? What do we put there? T. What does that mean? Tangent is what? Now, that's the only one that's positive. Does anybody want to tell me why? Because your x-coordinate is negative. That's what it means to be negative. Your y-coordinate is negative. Okay, what's the definition of tangent? Isn't it y over x? Negative over negative makes a positive. That's why we say tangent's what? Positive in quadrant 3. There it is. All students take calculus. You say, what does the C stand for? You guys know what C is? Cosine's positive in quadrant 4. And you say, why? Well, the x-coordinate, ladies and gentlemen, is positive, but the y-coordinate is what? Negative. So you say, why is this? What's the definition of cosine? It's the x-coordinate. See, by circular functions, x-coordinate. So there it is. Since it's positive, that means cosine's positive. So you remember all students take calculus. You guys want to see how it works now? You guys want to see how to use this information? What do you guys think? Did you guys know this before? Some of you guys might have. Some of you guys might. Who did not know it? Just curious. Okay, good. Good. I'm glad you guys are here. No, because we're actually after high school and middle school. So you guys know that's the beauty of leaving high school. You get to be what? Mature now, I guess. All students what? Take calculus. Good. 30 degrees. Let's see if you're awake. What was the terminal point here? 30 degrees. Is that square root of 3 over 2, comma what? 1/2. You guys okay with that? Isn't this the x-coordinate? And this is the what? Okay, so I'm going to put this here. This is square root of 3 over 2, and this is 1/2. Okay? And that's for 30 degrees. Now, what's the arc length? Is it pi over 6? You go, they're even going to ask me that? Yes, I got to convert the angle, right? Arc length. And then what sine? Sine was which coordinate? X or Y? Cosine was which coordinate? X, is that right? Tangent was Y over X. So what's the y coordinate? This is what, 1/2. And what is this? Square root of 3 over 2. What's tangent? You're going to have to do some arithmetic with tangent, aren't you? What do I mean? What do you guys think? What do I mean? What is this? What do I got to do? This tangent is 1/2 divided by square root of 3 over 2. Double check, because you guys know I'm barely drinking my coffee. Is that the y coordinate over the x coordinate? Do you guys know something here? You're looking at something called complex fractions. This is division, but it's vertical. Here's what I always say to do. You guys want to go far in math? Here is something you're going to see a lot of. I can write 1/2 divided by what? Square root of 3 over 2. You write it horizontally, left to right. And then you go, well, what do you do next? What's the definition of division? 2 over what? You flip that over, is that right? And you have cancellation. This is 1 over the what? Square root of 3. You guys okay with that one? Okay. And then what do I want to remind you guys of? Good job. What does that become? Square root of 3 over what? Over 3. Okay, you guys okay with this? So this is what they expect you to be able to do. Use your definitions and fill this in. And then, mind you, what's the cosecant? After this, you say, well, how do I get the others? What's cosecant? Well, isn't that the reciprocal of sine? So you say, oh, I'm going to take sine, I'm going to flip that fraction over, and 2 over 1 really becomes what number? 2. What about secant? What's that the reciprocal of? Cosecant, isn't that 2 over the square root of 3? Is that right? What do I do with this? How do you do that? You multiply top and bottom by what? Square root of 3 over square root of 3, and what does that give you? 2 square root of 3 over 3. And there you go. I'll say it again. I'm sorry.
How do you find the angle length and the coordinates for triangles for the terminal points of triangles that aren't special triangles? So
In this class,
angles of 27.
27.2 degrees. Take calculus. It's actually not done in this class. Special, only two triangles, which yes, it really means 3. Yeah. And, because you bring an interesting observation, but the answer is yes. Now, notice that, because don't let it all intimidate you. You go, oh, my God, how do I worry about, 38.5 degrees or 38.6235918? You got to use other tools. So that's the thing about math and in general is it builds on each other. It's sequential. Those other situations require other tools, more powerful mathematics to answer. And you go, well, they're going to have me use it in my calculator. I go, I know they're going to eventually to deal with applications, right? But really, this course primarily is based on only 2 special triangles. And that's what kind of you say to a class in the beginning, you go, all you have to know is 2. And then all throughout the semester, students, maybe because it's only 2, They think it's easy, but they never bother to learn it. You know, and so you go, well, all you had to do was 2. You know, so anyway, that's the idea. But it's not. It's a good question. You got to, you got to take other courses and pay more fees to get to there. You know, so that's kind of I mean, we can do some other things that are going to come up to find, like sine of maybe 15 degrees. That's true. But it's all based on your special triangles here. It's all based. The heart of the course is based on what I'm talking about right now. So you say, is that why you're going through this with a fine-tooth comb? Yeah. All these little details to answer these questions. And you want to know where it comes from, you know. Why do you think it's good to know where it comes from? Because you don't know where you're going to be in your life. They may ask you to do this from these first principles. Second thing is because it helps you understand and appreciate it and remember it. And then if you can actually understand where it comes from, then you can now create other things where those things come from. It's that experience you get. So anyway, so I'm going to go through this. Then I'm going to say to you guys, I'm going to show you how it all works, and I'm going to have you do the other one. But is everybody okay with what I just did? Yes. Oh, Sarah, I'm sorry. I can't see. Thank you. Where do we get cosine? Well, this definition here, it's the circular function for cosine. Oh, I'm sorry. It's cotangent. Okay. Did I?
You roll the secant on the cotangent.
Oh, okay. I wrote secant on cotangent. Ah. 2 square root of 3 over 3. Good. Ah, we're not done. I got excited. Okay. Sarah, it's coming. Cotangent's coming. I apologize. Cotangent, what's that definition? Where do you go to? Don't you go here to tangent? You need the reciprocal, right? So you can say that's 3 over the square root of 3. But what do? You rationalize the what? Denominator. And what is the answer? Is that the square root of 3? Mm-hmm. There you go. What do you guys think? Pretty good. Isn't using all the tools and definitions we talked about? So when I say, okay, fill in this table, I'm not going to say on a test. I did do that once. I gave them the whole table. They did that. But, I don't want to grade 183 things. So I have to be random. How do we use this information now? You say, what do you mean? 150 degrees. Okay, 150 degrees. Let me remind you guys of something here. Okay? How does that work if I say 150 degrees? You know how that works? You're going to start your ray on the positive x-axis. Yes, this is known as my what? And then you rotate how many? This is 90. Is that true? And then we have to rotate an additional how much? What would this be if there's 90? What would that be now if I rotate all the way down here? 60 degrees? So this portion here better be what? 60, because I'm going to rotate this way. You guys with me on this? Then what would this be if that's 60? Outstanding. So this is kind of how I visualize it. There. You guys see what I'm saying? Now, what do we just get through expressing here? I'm going to put this purple now. And that purple is my quadrant 1 information. You guys okay with this? What do we know in quadrant 2 now? You see how this is now the reference, the point of reference? Reference angle. I can give the address over here. But you want to know something? I'm going to try this without the address. This is why you care about that 30-degree angle. This is why you care about quadrant 2. Because you can just say this. I'm going to copy everything over. They are the same answers with one exception. Does anybody know what the exception about quadrant 2 is? Oh, what? Students take calculus. This is, S is positive. Only sine's positive. Well, sine and cosecant. The others are what? So go through this and say, oh, okay. Only sine's positive. Negative. Negative. Cosecant, nope. Negative, and what? Negative, right? And yes, we got to do x as well. You're right. So you say sine, what was the definition of sine? Circular function. The x or y coordinate? Y, so that means the x coordinate's negative. Yes. So if you went over here and you plotted that terminal point, you said, oh, x is going this is negative square root of 3 over 2, and this is positive, what? 1/2. So yes, your x coordinate's negative and your y coordinate's positive. You can do it this way if you wanted to. You could just simply go back to the circular functions and use, x being negative and y being what? Positive. Yes. Use the definitions and you could deduce it. But I use all students take what? Calculus. Okay, you guys okay with that? That's kind of how I use it. I always go back to my point of what? Reference. And then I think all students take calculus. But do I know where it comes from? You see, the right to use all students take calculus, it comes through knowing where it comes from. What about the third quadrant? What do you know about, what about the third quadrant? Tangent's positive, and so is what? Cotangent. Is that true? Okay. And so you go, oh, I'm going to go now to 210 degrees. Well, you might say first, how did I know this is 210? You want to know what angle this is, by the way? Oops, you guys don't even know because you can't see. Why is that 210 degrees? Yeah, you can think of 180 plus. How do you know that's 30, though? Because you're right. This is 30 degrees. That's what I started to say. You can't see my pencil. How do we justify that this is 30? Vertical angles, 30 and 30. So yes, you can now say what over here? This is 180 plus additional 30 gives you what? This is in regards to 210 degrees now. Okay? 180 plus 30, yes, is 210. And so, like I said earlier, let's see if I still have it there. No. I thought I copied this. I'm going to copy everything. This is quadrant 3, T. T is positive, tangent's positive, is that right? Yes. Yes. In quadrant 2, sine is positive. And then quadrant 3 is what? Tangent's positive. You know what quadrant 4 is? Cosine's positive. Because what's the acronym? All students take what? Calculus. Okay, go back to my website. See that there? All students take what? Calculus. It's kind of a summary. What do you guys think? Is that a nice summary? Nice picture? Spend a lot of time doing it. All students take calculus. So we're using that information now. And, okay, tangent's positive. What does that mean about sine then? What about cosine? Negative. What about cosecant? Negative. What about secant? What about cotangent? Positive. What about the two coordinates? X and Y. Oh, in quadrant 3, X is negative. Y is what? Negative. Every point. So negative, negative. Okay, you guys see what I'm saying? It's a pretty simple process if you know quadrant 1, geometry. Quadrant 1 is your point of reference. This is how I think about it in my mind always. Quadrant 1 is your point of reference. 330. What's this angle? Anybody know? This is 270. Is that right? I guess I'm going to have to change my colors now. What angle would this be, though? How do you know that's 60? You can do a couple of things here. You can say to me, well, and I got to find a nice color. I don't know. How about pink, pretty in pink? You guys probably don't know about that movie. It's another 80s movie. Huh? Heard of it? Isn't these opposite angles? So that's 30. Oh, that means this must be what? 60. So 270 plus 60, what does that give you? 330 right in here. Yes. So anyway, ladies and gentlemen, they're all related. It's 330. Okay? So this will be altogether 330 degrees. Yes.
I'm still a little confused. How do you find your arc length?
Oh, we'll go back and do that. Paste this. What quadrant is 330 in? Quadrant what? 4. Remember this. Always quadrant 1, your reference. Quadrant 2. Quadrant 3. Quadrant 4. Quadrant 4, all students take calculus. That means cosine is what? Positive. Okay, so cosine's positive. That means also then sine's negative, tangent's negative. If sine's negative, cosecant's negative. If tangent's negative, cotangent's negative. Is that right? I'm not even awake. I'm just using those terminal points, the coordinates being positive and negative. Oh, quadrant what? Quadrant what? 4. X is positive. Y is what? Negative. Is that right? Positive. X is positive. Good. Y is what? Negative. So you can actually deduce these on the unit circle, just using those terminal points. And then the question is, well, what about the arc length? Darn. I got to convert degrees to what? To radians. Now we're saying the arc length was the distance along this what? Unit circle. That's the S. How do you guys convert that? Do you guys remember? If you say 150 degrees, let me go to my trig scratch. Right? Remember this here? 150 degrees, ladies and gentlemen, becomes, I can go through every detail. Remember, I need a special unit ratio. That's the number what? 1. How do we represent 1? What unit ratio? I have only 2 options. I can use pi over 180, right? That's 1. I can use 180 over pi. That's 1. Which one do I use? I have to use pi over 180 degrees. You say, why? Because if your units are here, degrees, on top, in order to cancel, it must be on where? At the bottom. There's only one that will be that way. So now you say, what does this give me? Well, 150 pi over what? Get rid of the 0. What does that give you? 15 pi over what? 18. Are these both divisible by 3? 5 pi over what? 6. So, ladies and gentlemen, 150 degrees is 5 pi over what? 6. So you go back and say, where are we at? 5 pi over 6? No, wrong sheet. I got too many of them. 5 pi over 6. What was that called? I think you're right. Hey, that's the calculus class. 5 pi over 6. Do you guys know what the other angle will be? 210. What does that become? Okay. What about the last one? Okay, now you might say, why? Well, go to your scratch. Now, what was the other degrees? What was the other degree angle? You guys remember? 210. Pi over what? 180, gone. So this would be 210 pi over 180. 21 pi over what? 18. 3 goes into 21 how many times? And then 3 goes into 18 how many pines? 6. This is why it's 7 pi over what? 6. What was the other one? 330. Okay, and again, do you have to do it exactly like I'm doing this? You can start by putting pi over what? 180. Get rid of your pi. What is this? 330 pi over what? 180? 33 pi over what? 18? 3 goes into 33 how many times? 3 goes into 18 how many times? 6. 11 pi over 6. Circular functions. So that's where it comes from. Just trying to check something here. Okay, you guys okay with this? What do you think? Is that easy? Where's the other one? Which one is? Oh, we already did the 45, 45, 90. And I think here's a 60, 60. What was this terminal point? You guys remember? Was it 1/2? Square root of 3 over 2, the x and y coordinate. So this is going to be what? Minus 1/2, square root of 3 over 2. This will be down here. Minus 1/2, minus square root of 3 over 2. And then this over here going to be what? Positive 1/2, negative square root of 3 over 2. Is that right? And then what do we say? All what? Students take what? Calculus. So how do we deduce these others? Right? Remember, this is quadrant 1 information, your geometry information. So the x-coordinate is what? 1/2. And the y-coordinate is the square root of 3 over what? 2. Is that right? How do we define sine again? Is that the y-coordinate? X? Okay. So we say square root of 3 over 2. And what's this? 1/2. What's tangent then? Y over x, right? So it's square root of 3 over 2 divided by 1/2. Is that true? Y over x? And then you say, I know how to do some arithmetic, Mr. Judge. We're going to do what? I'm going to do it down here. I apologize. It's in that tangent. It's cosecant. 2 over square root of 3. Do we rationalize? Thank you. What does that give you? 2 square root of 3 over 3? Secant, reciprocal cosine. 2. Cotangent. 1 over the square root of 3. Is that right? But what does that become rationalize? Square root of 3 over what? 3. What's the arc length for 60 degrees? Where does 120 come from? Do you guys know? Because it's important to kind of know this as well. See this? This is your initial ray, right? On the positive x-axis. Remember, I'm going to say this is 90 degrees. Yeah, this is going to be 90 degrees, right? And then I'm going to say to you, what is this rotation now to get here? You're going to have to know, what is this angle? How do you know that's 30? A couple of things. Isn't this 30? Say yes. How do you know? 60 plus 30 is 90. And because it's a circle in symmetry, that means this has to be what? Which implies this is now what? Down here. 60. Just to throw that out there. Remember, circles have symmetry. They're symmetric. So it's nice about a circle. So that's why we use a unit circle. It's so symmetric. So this makes this degree here, this whole thing measures what? The central angle. Oh, it does an arc. I didn't know it did that. What is this going to be? 90 plus what? 30 is what? 120 degrees. You guys okay with that one? And it's actually right in here, in all honesty. That's 120 degrees because the arc length is not 120, right? Arc length is in radian measure. Just want to keep that clear for you guys. Okay, so this is now the 120. So what do we say? Should we pick somebody in the room? It's already there. Quadrant 2, what do you know about sine? Let's see who's awake. Anybody awake? Sine's positive. Your x-coordinate is what? Negative. Y-coordinate. So x is negative. Let's copy everything. That means what? Cosine and tangent are negative, which means secant and cotangent are negative. Do we have that okay? Did we make a mistake? I'm not awake yet. What's the 120 degrees? What's 12 over 18? You guys know what this arc length is going to be? It's 2 pi over 3. Is that true? There you guys go. What do you think? looking at the wrong thing. I apologize. Okay. Let's do this here. All students take what? Calculus. That means cosine's what? Positive. The x-coordinate's positive, right? So if cosine's positive, what do you know? Sine, tangent are negative, which means cosecant and cotangent are negative. Did I make a mistake on that one? Oh. All students take. You're right. T. T for what? Tangent. Tangent's positive. What does that mean? Both sine and cosine. Yeah. So they're both sine and cosine are what? Sine and cosine are negative. Cosecant and secant are negative. And what's that angle? 240. 4 pi over 3. On which one? Must have got rid of it. Okay. And in fact, this is kind of... Yeah, there we go. That's a lot better. Okay, now 300 degrees. That's the quadrant 4 version, right? Quadrant 1, 2, 3, and what? 4. You're right. It's incomplete. I'm rushing through this. I'm rushing. What's our time like? Okay. And I think we lost our denominators, right? Okay. 300 degrees. What's this? The x-coordinate's positive and the y-coordinate is what? Negative. So the quadrant 4, all students take what? Calculus. What does that mean? Sine. Yeah, cosine's positive. Sine and tangent are what? Negative. Cosecant and cotangent are negative. And what's the arc length? Is it 5 pi over 3? Yeah, we can talk more about this pattern, that you guys see here. So this was kind of what I wanted folks to look at this weekend and do and fill that in. Remember, did I say try to fill in the rest? So what you guys can do is now you have the reasons for why this exists the way it is, all based on circular functions, that terminal point along a unit, Randy Johnson, the big unit circle, okay? And, we're going to start to use this now. So, you guys have that already. I wanted to go over that. So what I'll do tomorrow is start to give you more book work. We'll start to do more things with this, okay? Yes. Nope. Okay. All right. See you guys later. You guys have a great day. Take care. who's here. Okay, good morning to everybody. Let's see, we have, so what you guys can notice here is this portion, if you do register, you get to put the little icon and your name and everything. So good morning, Caesar. Good morning to you. Hope you're doing well. Sarah, good morning. Lauren, good morning. Alice, good morning. And good morning to Blanca. Okay, good morning to all you guys. Okay, and then we have good morning to everybody here. So there's about 8 people at home right now, so you guys know. Hope you guys are doing well. Anyway, all right. So we want to kind of start to work with some of these ideas here, where we were working yesterday with the all students take calculus here, unit circle, right? And what I want to start to talk about now is this. What about negative angles? Yeah, you always want to, I mean, I do. I use the first quadrant as reference, but what about negative angles? But what I'm going to say here is, for example, if they said to you, they want you to answer what is sine of negative pi over 4, right? Something like this. And you say, well, how do I start to answer, these kind of questions, right? Sine of negative pi over 4. And there's various ways to do it. Cosine of negative pi, maybe tangent of, negative, how about this? Tangent of negative 2 pi over 3. Okay? So if you guys can see what I'm saying here, we want to start to talk about how to find these tangent of, or sine, cosine, and tangent, all these different, now as we have these negative angles here. And if you notice, what did they even give you here? If they said pi over, I guess I'll change the color. Pi over 4, I don't want to use red. Yeah. Pi over 4, pi, 2 pi over 3. What kind of measure is that? Right? You guys remember? What kind of measure did they give you here with these kind of questions? Yeah, this is in radian measure, right? Okay, so it's a good observation, radian measure. So we're going to answer, like, how do you actually answer those kind of questions? Well, I'm going to go back to this idea that here, circular functions, and we're going to use what's called these even and odd properties. Your book starts to, in 5.2, your book says, okay, we got these things called even and odd properties. So we're going to use these even and odd properties. And then you say, well, what are these even and odd properties? Well, here's what they are. If you have sine of negative s, cosine of negative s, tangent of negative s, right? They all equal something. They equal what we have up here, minus sine of s. This here is just cosine of s, and this is minus tangent of s. Right? These are what's called even and odd properties. So whenever you have negative angles, my recommendation is going to be to use these properties here. So notice what these properties are. I'll explain where they come from. See that negative sign? Right? The negative sign just comes out. You go, wow, that's pretty nice. See that negative sign? And you go, okay, what about for cosine? Well, it doesn't mean anything. You go, really? Yeah, that's nice. See that negative sign? Well, the negative sign comes out. Now, this is what we call an even property. It's really an even function. And this is what we call an odd property. And this is what we call an odd property. I'll give you the definitions, right? But we're going to first start to use this here. What's that? S. So here in the property portion, these are all S's for arc length. Okay? For the arc length S. Where's the... Okay, so sometimes what I'd like to say here to people is the following. You know, people like to say, well, where does this even come from, right? Well, go back here. These are the properties I described. So you might say, well, where does some of this stuff come from even? It comes from the circular functions. So here's what I'm saying, for example, here, right? Remember how this all works if I get the right tools. Right? You have your initial ray, and now if you had a positive angle, right in here. This is like positive theta. You rotate that ray. Let's get rid of that. Show you where it comes from. Here's my angle theta. Then here's the arc length they're talking about, right? Try to draw that arrow again. And this is S. So if you rotate counterclockwise, okay? This is counterclockwise rotation. You have a positive angle, positive what? Positive arc length. Everybody okay with that idea, right? Remember, we have this point over here. Your book is going to say you take that initial point and you have it over here. This is the what? Terminal point. Okay. And what is that address? You got an x coordinate and you got a y coordinate, right? Your x coordinate is positive and the y coordinate is positive, okay? So far so good. You guys know what's going on here? Nothing. Now what I'm going to do is this. I'm going to maybe change the color, I don't know, and say, what if you actually rotated in the other direction? And I'm going to try to draw it, see if I can do it. And what if you rotated in the other direction? And maybe we should change that color. Now I'm going to rotate this an equal length, minus theta. And so this terminal point down here, we're going to say, right? Now my theta, this is going to be what we call minus S. So if you rotate clockwise, theta is negative and your what? Arc length is negative. It's just an indication of direction. Clockwise direction. So it'll be negative that way, okay? Bless you. And so you have this X and Y here now, right? But what do you guys notice about that point? What's supposed to be true? X is positive, but what's going on? Y is negative. Is that true? So your X coordinate is the same. It's the Y coordinate now that's what? That's changed. Is that true? So far, so good? Everybody okay with that? Now that's the key. And you say, well, why is that the key? Well, look at what we're saying now. Sine S is defined to be the what? The Y coordinate. Is that true? And the Y coordinate now is what? Is negative. You guys okay with that? Okay. So you might say, well, what's the deal here then? Well, let's go back here. We have these circular functions. Sine S is defined to be the Y coordinate. Cosine is X. Tangent is what? Y over X. Okay, so let's try to see if we can figure this part out. Okay, so I want you guys to see this over here. These points there. It's all in the circular function. So let's see if we can prove this here. Okay, so sine of minus s now is going to be, they write it this way, minus the y value, okay? Where you remember sine s is what? Y, is that true? And so that really means negative 1 times what? Not sine s, or not y, but sine s. So what we're saying is sine negative s is minus sine of s. So this is where this comes from. Okay, it comes from the fact that the y coordinate value is now a negative value. And so they call that an odd function, whereas cosine doesn't change, right? Cosine minus s is that x value, which is the same as what it was to begin with, because it doesn't change. Cosine s is the same as x. So we have cosine minus s is cosine of s. And ladies and gentlemen, this is where they get, the second property, the even property, because back in here, remember what doesn't change? The x coordinate is the same. It's the y coordinate that is now opposite. And you might say tangent. Why is tangent s different? Well, if I told you guys tangent minus s is going to be negative y over x, because the y coordinate is now negative, right? Well, that's the same as negative 1 times y over x. Well, y over x, if you guys remember, is the definition of tangent s. So this is going to be tangent s. So now we have that minus tangent what s. So they're just going to define it that way for us, only because the y coordinate now is opposite. So the y coordinate being opposite changes everything when you go a negative angle. Now, these are called proof. This is a proof of the book calls even and odd properties. Okay? So this is the proof of this. Now, you might say, well, how do we use them? Very easy. I'm going to get this. I'm going to copy that. And just use the property. You say, what do you mean? What can I do with that negative sign? I can do what with that negative sign? What do you guys think? I can pull it out. Is that right? Is that true? Now remember what that is. That's negative 1 times what? Sine pi over 4. So if you can tell me what sine pi over 4 is, and by this time you guys should know how to do that, right? Remember, what's pi over 4 again? Isn't that 45 degrees? So all without a calculator, what's sine of 45 degrees, right? What if you said, I'm not sure, go to your special triangle. You guys remember I said that? You go, well, I don't know what that is, Mr. Judge. Okay, well then deduce it, right? Remember we did this? See if we can write. Square root of 2 over 2. Square root of 2 over 2. Here's my 90-degree angle. Doesn't want to do. Okay. This was 1. Wasn't that 45 degrees, your special triangle? So what is sine 45? You know, that's square root of 2 over 2. What's negative 1 times that? You guys know what that is? That's minus what? Square root of 2 over 2. So, ladies and gentlemen, there you go. That's your first negative angle, ladies and gentlemen. All right, you guys okay with that? Is that easy or is that hard? don't know. What was the next one we gave you guys? Cosine negative pi. So if they ask you for cosine of negative pi, let's take a look at this here just in case there's questions, right? Cosine of negative pi now, using the properties, you say, well, how do I deduce this, Mr. Judge? Well, cosine of negative pi is the same as cosine of what? Pi, because cosine again is what? Well, even. We use the even property, right? If it's the same, it's called an even situation. So you just have to answer what cosine of pi is. Now you might say, I don't know what cosine of pi is. Well, where is it? Remember this? You're going to rotate this what? You're going to rotate how? Clockwise, how many? Pi. 180? Right? How do you answer this question? You see that point? Negative 1, 0. Is that true? You guys with me on that? Negative 1, 0. So what's cosine? Is it the x coordinate or the y coordinate? So it's going to be what's your answer? It's negative 1. So cosine is going to be negative 1, ladies and gentlemen. And you say, why is that again? Because cosine by circular functions is the x what? It was the x coordinate. Those are the things that's how you deduce these answers, ladies and gentlemen, on your unit circle. It's the x coordinate value. What do you guys think? Is that easy or is that hard? You're going to have a test and I'm going to do these kind of questions. You go, oh man, are you sure, Mr. Judge? You're going to do that to us? Yes. What's the last one here? Tangent of negative 2 pi over 3? You go, how do I work with this one? This is going to be a good one too. Tangent of negative what? 2 pi over what? 3. Okay? So what do you know about tangent of a negative angle? Isn't that what? Isn't that negative tangent of what? 2 pi over 3? Is that true? You guys okay with that? Okay. All right. Then, and you say why? Because tangent is what? What is tangent? Tangent's an odd property there. So, whatever you get for this answer for tangent, it's going to be opposite. You guys agree with that? But now, here's what happens now, ladies and gentlemen. We have two things to be concerned with. What are the two things? I'm going to say focus on pi over 3. I know it says 2. Okay? What is pi over 3, by the way, in purple? That means like 60 degrees. So I know they're really saying what's tangent of 120. But you might say, why am I going to focus on that 60 degree? Well, I'm going to do this. Remember this here? That special triangle? I'm going to tell you guys a secret. I don't know what the answer is, but I know how to deduce the answer. Some of you guys have this memorized. I don't. This is what I remember. 2, 2, 2, especially since I have to wake up. Had that, right? And this is going to be square root of what? So in other words, my special triangle, this is 60. This would be 2. This is now half of 1, which is 2. And then this other side, remember, is going to be what? Isn't that the square root of 3? So far, so good? What do we need to know? Tangent of what? What's tangent of 60? Isn't that, what's the definition of tangent? Opposite over what? Adjacent? Isn't that square root of 3? So this is tangent of 60 degrees, and it equals what? This value here. Okay? So far, so good? All right, you guys with me on that? 60 degrees is a quadrant what? This is a quadrant 1 angle. This is my geometry. This is quadrant 1. This is my reference. Remember I said this over here? Point of reference? I got to find something. But this is not the final answer because the angle is 2 pi. It's not pi. How do I work with that 2 pi? What is 2 pi? Isn't that 120? Say yes. 2 times, I'm sorry. Pi over 3 is what, 60 degrees? What's 2 pi over 3? It's 120. What quadrant is that in? What do I know about this? What do I know about quadrant 2? Sine is what? Positive. So what does it mean about tangent then? It's negative. So what I'm saying to you guys is this information tells me that tangent of 2 pi over 3, because it's 120 degrees, is actually negative. It's not positive. And it's negative square root of 3. This is why we call this quadrant 1 the reference quadrant. Okay? All your information there is a point of reference. So if your angle is 120, that just means tangent has to be negative. That's tangent of 2 pi over 3 being negative. Okay, you guys with me on that? It's kind of a nice little thing to know. So like I tell you, I don't even know the final answer. I'm not even awake, and I can still deduce this. I know how to deduce the answer. That's what I'm saying to you guys. You want to focus on the art of deduction. So that's negative square root of 3. Okay? So you can kind of notate this and go, okay, this implies tangent of what? 2 pi over 3, which is 120 degrees, is not positive. It's negative because that 2 pi over 3 is in quadrant 2. Okay? Quadrant 2. Now, we're still not there. You say, why aren't we still there? Because all I know is this is negative what? Square root of 3. We need to now know what's the opposite of a negative. Because they asked us for negative 2 pi over 3. What is this going to give you guys? What's the opposite? That's negative 1 times negative square root of 3, which will be what? Positive square root of 3, ladies and gentlemen. Positive square root of 3. Now, you had a question like, hey, how do I know I'm right? Here's one thing that I would suggest you guys learn how to do as well, right? Let's go back here. I'm going to dig out my calculator here. You go, Mr. Judge, you're trying to show us how to do this without a calculator. I go, I know, because it's a very good skill to have. But if you said, I could look in back of the book to see if I'm right, you can. What else can you do? If you go to the calculator, where's my... Right? A couple of things you can do. First of all, where is pi on? Okay, there it is. Go to the mode on this thing and make sure it's in what? Degrees or radians? I can say degrees, but this is a radian question, right? So make sure it's on radians. So tangent of down here, let's see if you guys, yes. Tangent of negative what? 2 second pi. Is that a pi? That looks like an E. Second pi, there you go, divided by 3. Close that, and what do you get? A numerical answer. I don't know what that is. Okay. Second, where's my square root? There we go. Square root of 3. What did I just verify? it's the same. See what I'm saying? So you can verify, and it might be good to just verify that it's the same. Yes.
So how did you get that? Because we used the degree of 60 and not 120.
Yeah, that's the key. This is the key. This is where sometimes, for example, let me go back over here. I'm going to give you another example. Right? What if they gave you cosine of negative 5 pi over 4? You go, Mr. Judge, 5 pi over 4. Negative 5 pi over 4? Okay, you guys with me on that one? Well, first use the what? The fact that cosine is what? Even or odd? Cosine's even. Okay? And then, what do you need to know? Pi over 4? In purple? You see, because this here is a multiple of what? Pi over 4. Is that true? This is how you do it. So answer this question first. You got to have this reference. This is where geometry comes in. You go, oh, Mr. Judge, I took that course in geometry. I know cosine pi over 4. This is your reference quadrant. This is quadrant 1. Right? I'm going to put that reference there because this is my point of reference. It's like your compass. Now you're golden. You go, what do you mean I'm golden? I want you to know pi over 4 is in quadrant what? 1. But 5 pi over 4 is in quadrant what? Where's the 5 pi over 4? That's the real question. What's 5 pi over 4? What quadrant is that in? Well, 5 times 45 degrees is really what? Is it 225? Haven't we talked about even conversion? Right? 225. Okay, go back. Go back. 225 degrees. All right, I guess I have to do this. Where's 225 degrees? Anybody know in the unit circle? 225. Well, this would be 90. This would be what? 180. What would this be? This would be 270. Oh, what number did we say? 225? Looks like it's in quadrant what? 3. What do you guys know about quadrant 3? Tangent is what? Positive, because all students take what? Calculus, but cosine is negative.
So then what you're doing is you're basically taking like the reference angle, then you're multiplying it by
By that multiple, just finding where 5 pi over 4 lives, and use all students take calculus. So final answer? Negative square root 2 over 2. Because you're using the reference angle, quadrant 1 angle. That's why they call it a reference angle. There it is, ladies and gentlemen. And then they might even get very sneaky on you. I'm going to say note. What if they gave you secant of negative 5 pi over 4? And you have to deduce this all without a what? Calculator. And when they give you a secant, and you go, oh my God. What do you guys use first? It's 1 over what? Cosine of what? Isn't that what secant is, a reciprocal of cosine? Is that true? And you go, oh my God, but cosine is what? Cosine is even. Is that true? And then you go, oh, 5 pi over 4. We know where that is. Reference 5 pi. I think we just found that. What was that? 1 over square root of 2 over 2. And I think that was what? Negative. Is that true? So my final answer is going to be what? Negative. But this is 1, right? So I'm going to do every detail. I can say that's going to be negative 1 times what? This is every gory detail. Square root of 2 over 2. Negative 1 divided by square root of 2 over 2, which is negative 1 times what? 2 over the square root of 2, which is negative 2 over the square root of 2. Yes, you can rationalize. What is this? Final answer is what? Negative square root of 2. I did all the arithmetic here. So it's minus square root of 2. So they can even ask you questions like that, and notice we're using all the little details we went through over. All the details. What do you guys think? Should we try another one? Tangent of, how about this? Ooh, we'll really get interesting here. Tangent of 5 pi over 6. Oh, we've got to put a negative sign. Negative sign. Let's go through the logic. Tangent is what? Even or odd? And so that means I pull out my negative sign. I wouldn't say because it's an odd function. I would even justify it. So far, so good? Then what do I focus on? See that pi over 6? What is this? Yeah, that's 30 degrees, right? So far, so good? And you know what I would even do? If I were you, I'd write down these triangles. You get your test. You guys ever know that little trick? Write down your 2 special triangles. 45, 45, 90, and then 30, 60, 90. And then you just start using your definition here. So what do I know about tangent? This is not 60 degrees now. It's what? 30. This is my geometry region, quadrant 1. So go back to trig. What's tangent pi over 6? What's the definition? 1 over what? Square root of 3, which will be square root of 3 over 3. Is that true? Because isn't tangent 30 degrees what? Opposite over adjacent? Opposite over adjacent? You guys okay with that? And then we rationalize? So far, so good? So use your quadrant 1. But what's the deal here, though? This is a multiple of pi over 6. That's 5 times pi over 6. Or 5 times 30. What's 5 times 30? 150. What quadrant is that? Isn't 150 in quadrant what? Quadrant 2? All students take what? Calculus. What about tangent there? Tangent's what? All students take calculus. Tangent's positive in quadrant 3. Okay? You guys see, this is why we look for all those quadrants. All students take calculus. In other words, tangent is positive. It's the same answer. So, okay, so you say, what does that mean? that means tangent 5 pi over 3 is the same. It's the same here. Square root of 3 over 3. So you just found what this is. Again, a negative times a positive, though, is what? Negative. Don't forget, you already had the what? Negative sign right out here. So here's your final answer. So this is using, ladies and gentlemen, all the details that we talked about. So you can find sine, cosine, tangent for negative angles as well. What do you guys think? Is that pretty good? Should we have you guys try a few? See if you wake up. I'm not even awake. Anybody here awake? Fishing would have been better. Yeah. I don't know. Maybe this is better than fishing. Maybe we could do this while you fish. I'm going to give you guys some examples. I'm just looking at your book. Okay. Secant negative pi over 3, number 1. Number 2, tangent 11 pi over 3. Number 3, cotangent negative pi over 2. And number 4, sine of let's say sine of 7 pi over 6. Whew. What time is it? Let's get out the clock. See what you guys get here for these, okay? All right, try this out. Sorry, we got back. Thank you so much. Yeah, there's sound. I'm sorry about that, Sarah. Sorry about that, Blanca. I'm glad you're awake. I didn't hit the sound button. I was on mute. What I got through saying is I'm writing down some reciprocal identities to help people remember that we're using these kind of things. So these are known as the reciprocal identities, and we'll see these in our future. So anyway, what do I say now? Cosine of minus an angle is simply cosine of the angle. What property is that? That's even, because cosine is an even function. Remember that? Even? They wrote those down? All right. Now, what's nice about pi over 3? You know what's nice about pi over 3? It is 60 degrees, I think. I'll believe you. What should I do? Go back over here. Go back to your what? You know what I'm sitting here thinking of doing? On your test, question 1. Draw the 2 special triangles. What do you think? Oh man, that's good. Draw the 2 special triangles, 45, 45, 90, and 30, 60, 90. Question number 1. And then you say, why would you do that, Mr. Judge? Because people can use that. What's cosine of 60? I didn't want to erase that. What's cosine 60? You guys remember? It's going to be what? Oh, I got to remember. Cosine is adjacent over hypotenuse. 1 over 1 divided by 2. That's by definition of what? Cosine. They didn't do the multiple business here. Notice that? Now, arithmetic. Do you guys know what this is? 1 divided by 1/2. And what does that become? You guys know what that becomes? 1 times 2 over 1, or 1 times 2. The answer is what? 2, ladies and gentlemen. Take a look. What do you guys think? You guys see every detail there. We wrote every detail. That's what you guys do. Is that okay? You see how that worked? I'm going to do a note here just to see if you're awake. Note. What if they gave you secant of negative 4 pi over 3? Okay? You say, would I write that again as 1 over what? Cosine of that negative 4 pi over 3? Yes, this is compare and contrast. And you say, can I use the fact that cosine is even? That's what they want you to do. And then again, here you're focusing on what? Pi over 3, which was, what is pi over 3 again? 60 degrees. Now, what did you know about this, right? Cosine of 60 degrees, I think we said was what? Was that 1/2? Is that true? I think we did. You say, where was that? Right in here. We use this special triangle, cosine 1/2. But then you have to know, what is 4 times 60? Anybody know? What's 4 times 60? Is that 240? What quadrant is a 240-degree angle in? Right? All students take calculus. Is that quadrant 3? Okay. All students take calculus. What do we know? It's quadrant 3. Cosine is what in quadrant 3? Remember that acronym? All students take calculus. Tangent's positive. Cosine's what? Negative. So every cosine will be negative here. And let's see what that means. That means what? That this is actually what? Negative what? 1/2. That's the point of all students take calculus. Okay, that's why you wanted to learn that. All students take calculus. So that now, what do you have? 1 divided by a negative 1/2, which is going to give you negative 2. Okay, you guys okay with that? Just to compare and contrast, do an extra one where you had to use that all students take calculus. Pretty good? What do you guys think? Is that clear? All right, what about tangent now? What do you guys notice about this? There's no negative sign, so you don't use even and odd, do you? You just focus on what? What's this pi over 3? Isn't that 60 degrees? Question 1 on the test. Draw the 3 special triangle. It's really 2. What's the definition of tangent? Right? Tangent of pi over 3, which is 60 degrees, is, what's this, opposite over what? Adjacent. Is that true? So far, so good? Reference. Okay, now deal with this multiple. Oh my God, 11 times 60? Holy moly, what is this? What is it? What's 11 times 60? Is that 600? This is a 660-degree angle. You can deal with that kind of stuff? Yes, you can. What do you guys notice? 306, is that 660? Remember, I'm not even awake. I'm semi-medicated. Is that true? 660? I'm going to do this. 660 minus, what is minus 360? Is that 300? Is that true? Why did I subtract 360? That's 1 revolution. Good, 1 revolution. So ladies and gentlemen, let's go back over here again. Okay, I don't want to do that, but 1 revolution is actually 360 degrees. Is that right? And then I have to go another how much? So I'm like saying this to you. I had to revolve that ray. That's 1 rotation. And then I have to go an additional what? 300 degrees. So in other words, this is in quadrant what? 4. What do I know about quadrant 4 angles? Since all students take calculus, what does that mean? Cosine's positive, but that means tangent's what? Negative. And yes, sine is negative. So what are we looking for? Is it tangent? That'll be what? Negative. Okay? So just put the negative sign. So, okay, what's I just put negative sign? Yeah, just negative sign. Where is this thing at? Final answer. Negative what? Square root of 3. And that's all you do. Final answer. Is that using everything we talked about? It's putting it all together. So there's some detail there. I guess that's why they make the prerequisite like geometry, you know. Okay, what is this? Cotangent, 1 over tangent of what? Negative pi over 2. That's a reciprocal identity. And then you got a negative sign. What do? Pull it out. That's 1 over tangent of what? Pi over 2. Because tangent is what? That's odd. So we have to find What's tangent of pi over 2? Uh-oh. Anybody know what that is? It's tangent of pi over 2. You guys know where pi over 2 is? Yes. Isn't that 90 degrees? What's that terminal point? So tangent of 90 degrees is what? Is that undefined? It's 1 over 0. Is that right? Is that true? What do I do with this? That's 0? You know what I can also do? I can say cotangent of minus an angle is minus cotangent of the angle. Why can I say that? In other words, cotangent is also what? Odd. Is that true? Is cotangent an odd function because tangent's odd? Yes. So if you said to me, can I just do this? -1 times cotangent of what? Pi over 2? And I'll say yes. And what's cotangent? Isn't that 0 over 1? Is that true? So that'll be equal to -1 times 0, which is what? 0? Isn't that what we got when we deduce it this way? So we can say the same thing about cotangent. Cotangent's an odd function, really. Isn't that kind of interesting? Okay, what about secant? Our sine. Well, notice this. They did not give us what? A negative sign. So we need to know what sine of, what's pi over 6, by the way? 30 degrees. So we're going to go to our special triangle. What's sine of 30 degrees? Anybody want to tell me? What's the definition of sine? Opposite over hypotenuse. So sine is what? 1/2. Is that true? However, now, don't we need to deal with a multiple? What's 7? 7 times 30 is 200 and what? What quadrant is this in? Quadrant 1, quadrant 2, or quadrant 3? All students take what? Calculus. Isn't this T in quadrant 3? So what does that mean about sine? Sine is what then? So final answer is negative what? 1/2. And that's how you deduce this. That's how you use the all students take calculus. So we went through the gory details of why all students take calculus exists, those terminal points, why you can use it. So hopefully you guys are now like true believers of that kind of thing, right? Answer is -1/2. Okay, you guys okay with that? What do you guys think? Is that pretty simple? Well, you say, well, maybe not. I want to go there. But if you go and take a look at this here, I went to go to the assignment portion, right? You know what I added to your homework list? What's at the bottom there? Let's see if you guys, can you see that? Maybe not. Right, what did I add? 5.2, 3 to 23 odd. Maybe you should do them all. I don't know. Should you do them all? What do you think is on that? Everything that we just did today. So in other words, it's trying to find sine, cosine, tangent of negative angles. Some of them are positive angles. They didn't put negatives there. So it's the stuff we worked on here, ladies and gentlemen, today. It's these kind of things. And notice it's actually using every gory detail of what we were talking about, everything that we've been doing. You know, with the exception of maybe writing down the reciprocals this way. But, you know, this is the deal. So like on your first task, I just thought of question 1. Draw your 2 special triangles. Let's see who misses it. What do you guys think? You guys know what I mean? Anybody gonna miss that question? That's a geometry question. It's quadrant 1. It's a reference. I'm thinking, yeah, put that down. And then we should put your name on the board, right? If you miss it. So who missed that one? It's like saying, did you forget to bring your shoes this morning? Anybody forget your shoes?